Hello and welcome. My name is Sunshine, the Project Manager, Sunshine Educational Resources. At Sunshine Educational Resources, we also assist science students in the senior secondary school with revision techniques, especially when they are preparing for either termly school examinations or standard examinations like the Senior Secondary School Certificate Examination SSCE, National Examination Council NECO, or the Joint Admission and Matriculation Board Examinations JAMB. We do all this using our YouTube channel. Let me show you how to use our resources to aid your revision using this particular video. In this video, we will provide you with 10 questions drawn from different past question papers in chemistry. I will go through the 10 questions and I recommend that you follow me as I do that. The task you will perform here after we have gone through the 10th question is to pause the video and try to solve the problems one by one. When you finish solving the problems, now resume the video and compare your answers as I solve them with you. For effective learning outcome, please make sure you follow the instructions I've given you in this video. Now let's move on. Alright, now we're going to go through the question one by one, after which you are expected to pause this video and solve the problems one by one. When you complete solving the questions, you can return to the video again and compare your answers. The first question that I have here is, given that 32.0 gram of sulfur contains 6.02 times 10 raised power 23 sulfur atoms, how many atoms are there in 2.70 gram of aluminium? Aluminium is 27 and sulfur is 32. Let me take the question again. Given that 32.0 gram of sulfur contains 6.02 times 10 raised power 23 sulfur atoms, how many atoms are there in 2.70 gram of aluminium? You have aluminium 27 and sulfur 32. Question number 2. What quantity of silver is deposited when 96500 coulombs of electricity is passed through a solution containing silver ions? Silver is 108, 1 Faraday is 96500 coulombs. Let me take the question again. What quantity of silver is deposited when 96500 coulombs of electricity is passed through a solution containing silver ions? Silver is 108, 1 Faraday is 96500 coulomb. Question number 3. What volume of oxygen will be left unreacted when a mixture of 100 cm3 of hydrogen and 200 cm3 of oxygen are exploded in an audiometer? I'll take the question again. What volume of oxygen will be left unreacted when a mixture of 100 cm3 of hydrogen and 200 cm3 of oxygen are exploded in an audiometer? Question number 4. During the electrolysis of dilute tetraoxosulfate 6 acid solution, 0.05 moles of electrons were passed. What volume of gas was produced at the anode? Gaseous molar volume 22.4 dm3 at STP. I'll take the question again. During the electrolysis of dilute tetraoxosulfate 6 acid solution, 0.05 mole of electrons were passed. What volume of gas was produced at the anode? Gaseous molar volume is 22.4 dm3 at STP. Question number 5. 50 cm3 of sulfur 4 oxide was produced at STP when some quantity of powdered sulfur was burnt in excess oxygen. Question number 1. Write equation for the reaction. 2. Calculate the volume of oxygen used up during the reaction. I take the question again. 50 cm3 of sulfur 4 oxide were produced at STP when some quantity of powdered sulfur were burnt in excess oxygen. A, or number 1 rather, write equation for the reaction. 2. Calculate the volume of oxygen used up during the reaction. Question number 6. Write the structural formula of 2,2,4-trimethylpentane. I'll take the question again. Write the structural formula of 2,2,4-trimethylpentane. Question number 7. An element X is represented by this symbol here, X 40 up and 20 down, just like you can see. Now here are the questions. How many electrons and how many neutrons are present? Question number 2. Write the electronic configuration of this atom called X. Question number 8a. Name 2 allotropes of carbon. 8b. Name 2 products of the destructive distillation of coal and state 1 use for each. Question number 8a again. Name 2 allotropes of carbon. 8b. Name 2 products of the destructive distillation of coal and state 1 use for each. Question number 9. Arrange the following in the order of increasing energy: alpha particles, gamma rays, and beta particles. Question number 9. Arrange the following in order of increasing energy: alpha particle, gamma rays, and beta particles. And the last question, question number 10. Give one example of the following: 1. Heavy chemicals. 2. Fine chemicals. 3. Write the structural formula and the name of the compound having the formula C2H4Cl2. I'll take the question again. Question number 10. Give one example of 1. Heavy chemical. 2. Fine chemical. 3. Write the structural formula and name of the compound having the formula C2H4Cl2. You may now pause your video and solve the problems. Alright, now let's go into solving this problem. The first question. Please, before you start solving any problem, make sure you understand the problem very carefully. Try to get a link of where this problem is coming from, and then you try to harness the ideas that you need to be able to solve this problem. The first information that you're going to decode from here now is that you're talking about a number 6.02 times 10 raised to power 23, and this number is called Avogadro's number. And this number appears in Avogadro's law, which says that 1 mole of any substance contains 6.02 times 10 raised to power 23 species. Species here could mean atoms, molecules, or ion. So as you can see here, the question says, given that 332.0 gram of sulfur contains 6.02 times 10 raised to power 23 sulfur atoms. Now, the idea to extract from this information shows that this 32 gram is 1 mole of sulfur. Okay, so 1 mole of sulfur contains 6.02 times 10 raised to power 23 sulfur atoms. Now, the question says, how many atoms are there in 2.70 gram of aluminium? So the first thing we need to do now is to find out how many grams has 1 mole of aluminium. 1 mole of aluminium has 27 grams. That is a fact that we know, because here is given to us aluminium is 27. So it means that 1 mole of aluminium is 27 grams. So if 1 mole of aluminium is 27 grams, that means that 1 mole of aluminium contains 6.02 times 10 raised to power 23 aluminium atoms. Now, from the fact given to us in this question, it means that 27 grams of aluminium contains or will contain 6.02 times 10 raised to power 23 aluminium atoms. Now, if that is the case, 2.7 grams will contain unknown. Now let's do the mathematics. 27 gram over 6.02 times 10 raised to power 23 is equal to 2.7 over unknown. We can use x to denote the unknown, or Y or any number, any letter, sorry. Okay, now let's cross multiply now. 27x is equal to 6.02 times 10 raised to power 23 times 2.7. Now your unknown, which is x, is equal to 6.02 times 10 raised to power 23 times 2.7 all over 27. Or you can just divide both sides by 27 if you want. Alright, let's solve this mathematics now and get the final answer. Alright, from the last expression we had, x is therefore equal to 6.02 times 10 raised to power 23 times 2.7 all over 27. Okay, now let's break it down further, which is equal to x is equal to 6.02 times 10 raised to power 23 times, instead of writing 27 here, we're going to write 2, instead of writing 2.7 here we'll write 27 times 0.1. 22.7 is the same as writing 27 times 0.1. You can bracket it if you want, and you divide everything by 27. Now what we're going to do now is to cancel this 27. We cancel 27, and then you have x is equal to 6.02 times 10 raised to power 23 times 0.1 is the same as writing 10 raised to power minus 1. And so finally x is equal to 6.02 times 10 raised to power 23 minus 1 is equal to 22. I hope you know how we got this answer. The law of indices and mathematics, you have to subtract the index while you are multiplying. So 23 minus 1, you get 22. So finally you have x, which is the unknown, is equal to 6.02 times 10 raised to power 22 aluminium atoms. So this is the final answer. If your answer is 6.02 times 10 raised to power 22, that means you are right. Alright, question number 2 says that what quantity of silver is deposited when 96500 coulombs of electricity is passed through a solution containing silver ion. Silver is 108 and 1 Faraday is 96500. Obviously this problem is from electrolysis. Before you can solve this problem, you must be conversant with electrolysis. Now the first thing we're going to do here is to identify silver. Identify silver as either a univalent element, a divalent element, or a trivalent element. So from our studies, silver is a univalent element and can be represented as this, Ag+. Now we're told in the electrolysis that silver is being deposited. That means that silver is going from ion to atom, and for silver to go from ion to atom, it has to abstract one electron. That means that something like this will happen. Silver ion will abstract 1 mole of electron to become silver atom. Silver ion will abstract 1 mole of electron to become silver atom. Now from this reaction, it means that 1 mole of electron will give 1 mole of silver, and this 1 mole of electron is also the same thing as saying 1 Faraday. 1 Faraday of electron was abstracted by silver to give 1 mole of atom, silver atom. So it means also that 1 Faraday will liberate 108 gram, and we're told that in the equation, in the
question, we are told that 1 Faraday was passed through the solution, and 1 Faraday is 96500 coulombs was passed through the solution. Then it will definitely liberate 108 gram, and our answer now is 108 gram. Alright, question number 3 says that what volume of oxygen will be left unreacted when a mixture of 100 cm³ of hydrogen and 200 cm³ of oxygen are exploded in an audiometer. Alright, the first thing we're going to do is to write the chemical equation for this reaction. Write a well-balanced chemical equation for this reaction, and the equation goes like this: hydrogen react with oxygen to give water vapor. Now let's balance the equation. In balancing the equation, we're going to insert 2 here and also insert 2 here. Remember, when balancing chemical equations, you do it by trial and error. When you place the numbers in front of either hydrogen or oxygen, then you have to check to see if it is correct. If it's not correct, you will have to try again. Alright, let's see if the equation is balanced. Here you have 4 atoms of hydrogen on the left hand side, and also you have 4 atoms of hydrogen on the right hand side. Now let's see oxygen. Oxygen on the left hand side you have 2 atoms, and on the right hand side you have 2 atoms. It means that the equation is balanced. Now from this equation we are going to apply Avogadro's law or Gay-Lussac's law to this equation, and that means that from this equation 2 volumes of hydrogen reacted with 1 volume of oxygen to give 2 volumes of water. So it means that this reaction takes place in the ratio 2:1:2. So it simply means that each time we're going to react hydrogen and oxygen to give water, when we take 2 volumes of hydrogen, then we will take 1 volume of oxygen to give 2 volumes of water. Now let's see, from the question we're told that 100 volumes of hydrogen was used. 100 cm³ rather, let me use cm³. 100 cm³ of hydrogen was used. Now this simply means that out of this 100 cm³, 50 will be taken, because the ratio is 2:1. 2:1. If you take 100 here, then 50 of it will be consumed to give 100 of water. But we're told in the equation that 200 cm³ of oxygen was provided. 200 cm³ of oxygen was provided. But 50 from this expression here, 50 was consumed. So 200 minus 50 will be left with 150 cm³ unreacted. So 150 cm³ of oxygen was unreacted. So our answer is 150 cm³. Alright, question number 4 says that during the electrolysis of dilute tetraoxosulfate 6 acid solution, 0.05 mole of electrons were passed. What volume of gas was produced at the anode? And then they said gaseous molar volume is 22.4 dm³ at STP. Alright, for you to be able to solve this problem, you have to be conversant with electrolysis. Electrolysis is the process whereby substances are broken down by the passage of electric current. And so the two important reagents involved in this dissociation or decomposition is tetraoxosulfate 6 acid and water. So let's look at the ions that are involved when these two elements dissociate. So the first one is H2SO4, and it will dissociate into 2H plus SO4 2 minus, and the medium, which is water, will dissociate into H plus OH minus. So these are the ions that are involved. Now, because it is an electrolysis, so the ions will take their position in the cells. So here we have the anode, which is the positive side of the electrode, and then you have the cathode, which is the negative side of the electrode. So the positive side of the electrode, you have the SO4 2 minus and OH minus, and at the negative side of the electrode you have H plus, just H plus there. Okay, now which of these elements will be discharged? Because of the high stability of SO4 2 minus, very stable, so it will not be discharged. In place of SO4, OH minus will be discharged, and it will move through the anode. This is what happened at the anode.
OH minus will lose one electron to become OH. Another OH minus will lose one electron to become OH.
And then the two OH group react to form H2O, which is water, plus one atom of oxygen. Now, in this reaction, we just got one atom of oxygen. For us to be able to get another atom before it can form a molecule of oxygen, this reaction will have to repeat itself. So it's going to be times 2 of this reaction. Let me complete the process.
OH minus will lose one electron to become OH. Another OH will lose one electron to become OH.
Then OH plus OH becomes H2O plus O. Now we have two atoms of oxygen. So the two atoms of oxygen will now react to give a molecule, to give us a molecule. So now we're going to sum up all these reactions together in form of, let's do a summary of all these reactions together now.
4OH ion loses 4 electrons to become 4OH.
So this means that before one molecule of oxygen was formed, 4 moles of electrons were lost at the anode. 4 mole electron. So this means that 4 moles of electrons will give 2.4 dm cube of oxygen at STP. Then in the question we are told that 0.05 moles of electrons were passed. So if 4 moles of electrons will give 2.4 dm cube of oxygen at STP, then 0.05 moles, which is the amount of moles of electron that was passed through the solution, will give us an unknown volume. Now let's do the calculation. So you said 4 over 22.4 is equal to 0.05 over x. X here is the unknown, so 4x is equal to 22.4 times 0.05. So divide both sides by by 4. 4 will cancel 4. So if you multiply these together, 22.4 times 0.05 over 4, Your answer is 0.28 dm cube. Answer is 0.28 dm cube. That's the final answer. Alright, question number 5 says that 50 cm cube of sulfur 4 oxide were produced at STP when some quantity of powdered sulfur were burned in excess oxygen. Question number 1, or A, write equation for the reaction. And the second question to number 5 says calculate the volume of oxygen used up during the reaction. Okay, the first thing is that to write the chemical equation for this reaction. Sulfur reacting with oxygen to give sulfur 4 oxide. This is the formula for sulfur 4 oxide. This is solid and this is a gas, and this is also a gas. Alright, let's balance the equation. Alright, now let's see whether the equation is balanced. Let's see the number of sulfur atoms. On the left hand side you have 1, and on the right hand side you have 1. Let's see the number of oxygen atoms. On the left hand side 2, and on the right hand side 2. The equation is balanced. The equation is therefore balanced. Now let's look at the volume ratio. Let's look at the volume ratio. For the oxygen is 1 volume, and for the sulfur 4 oxide is also 1 volume. We're told in the question that 50 cm cube of sulfur 4 oxide was produced. So let's indicate it. 50 cm cube was produced. Now from the volume ratio here, since 50 cm cube was produced, it means that 50 cm cube of oxygen was consumed. It means 50 cm cube of oxygen was consumed. So question number A, or 1, the equation is balanced, and the second one is 50 cm cube of oxygen was used up for the reaction. Question number 6 says that write the structural formula of 2,2,4 trimethylpentane. The structural formula of 2,2,4 trimethylpentane. This is coming from organic chemistry and hydrocarbon, to be specific. The hydrocarbon that we are talking about here is called pentane. Pentane, that's the longest chain here, contains 5 carbon atoms. 5 carbon atoms, and it has a branch chain of a methyl group at the second carbon atom, and at the second carbon atom again, and at the fourth carbon atom. Now you can start from any direction. First and foremost, the first thing you do is to write down the longest chain. That is 1, 2, 3, 4, 5. So here we have 5 carbon atoms designating pentane. So we can start counting from any side, either from this side or from this side. You can start counting from any side, but let's start from here. So in the question we're told that 2,2,4 trimethyl. So if this is the first carbon atom, this is the second carbon atom, and we're told that at the second carbon atom there is a methyl group that is attached to this, and at the second carbon atom again there is another methyl group that is attached to this, and we're told that at the fourth carbon atom also 1, 2, 3, 4. At the fourth carbon atom also there is another methyl group that is attached to this. So this is the structure of 2,2,4 trimethylpentane. This is finally the structure of 2,2,4 trimethylpentane. pentane. This is a saturated hydrocarbon. Alright, question number 7 now. An element X is represented by symbol X, and you have 40 at the top and they have 20 down. This 40 here is the atomic mass. And this is the atomic number. This is the atomic mass and this is the atomic number. So the first question says, how many electrons and how many neutrons are present? How many electrons and how many neutrons are present? Obviously, the number of electrons is equal to number of protons. The protons plus neutrons is equal to the atomic mass. So if the atomic mass is 40 and the number of electrons is 20, it means that the number of proton also is 20. So to get the number of neutrons, you will say 40 minus 20, which is equal to 20. So number of neutron 20, number of electron 20. So number of neutrons is equal to 20 and number of electrons is also equal to 20. Now the next question says, write the electronic configuration of the atom. We use the number of electrons in writing down the electronic configuration. Number of electrons, so we have 20 electrons, and so we're going to write the electronic configuration this way. So let's see, we're going to use the SPDF system. 1s2, 2s2, 2p6, and now the 3s, 3s2, 3p6, and 4s2. When you add this number, 2 plus 2 plus 6 plus 2 plus 6 plus 2, it's going to give you 20. That's the number of electrons. So this is your answer. And obviously this element is calcium. As students preparing for SSCE, you are expected to be familiar with the first 20 elements in the periodic table, in which calcium is one of them, and obviously the last 20 elements in the periodic table. So you are supposed to be familiar with the first 20 elements, especially their electronic configuration in the SPDF system. Question number 8 says, name 2 allotropes of carbon. 2 allotropes of carbon. And for you to be able to answer this question, you must have studied carbon and its compound. And allotropes, 2 allotropes of carbon here are diamond and graphite. Diamond and graphite. These are the 2 popular allotropes of carbon. Now the second question says, name 2 products of the destructive distillation of coal and state 1 use for each. 2 products from destructive distillation of coal are coal gas. You have coal gas, and you have also coal tar. Coal tar. Coal gas is used as an industrial fuel. Coal gas is used as an industrial fuel, and coal tar is used in producing perfumes. Coal tar is used in perfumes. It's also used as disinfectant. Coal tar is used in perfumes and is also used in disinfectant. Alright, question number 9 says, arrange the following in order of increasing energy. Arrange the following in order of increasing energy. First, you have the alpha particles. And then you have the gamma rays. And then you have the beta particles. Alpha particles are made up of helium nucleus in rapid motion. Gamma rays are electromagnetic radiations. They are made up of photons. And beta particles consist of electrons in rapid motion. So the energy increases as you go down. In other words, beta particles are more energetic than gamma rays, and gamma rays are more energetic than alpha particles. Alright, question number 10 says, give one example of each of the following. Number 1, heavy chemical. Number 2, fine chemical. And number 3, write the structure of C2H4Cl2. Write the structure and name of the compound C2H4Cl2. A very good example of heavy chemical is H2SO4 tetraoxosulfate 6 acid. This acid is used for manufacturing broad spectrum of product in the chemical industry. And a very good example of fine chemicals are additives for fuel. Fine chemicals are usually produced with high level of purity. Additive for fuel is a very good example of fine chemical. Now let's write the structure of C2H4Cl2. 2 carbon atoms, 4 hydrogen atoms, and 2 chlorine atoms. So this compound is called 1,1-dichloroethane. 1,1-dichloroethane. We can also arrange this structure like this. You can also arrange this structure like this. The structure can also be arranged like this, and this one is called 1,2-dichloroethane. These compounds can be produced through substitutional reaction of the alkanes with the halogens. Substitutional reaction of the alkanes with the halogens.
When you compare your answers, even if they are wrong, do not worry. The mistakes you have made is part of the learning process, but make sure you correct yourself by trying to understand how we got the right answers. When you correct yourself consciously, then you will never make the mistakes again. Of course, children learn how to walk by first falling down. It's part of the learning process. We've come to the end of today's lesson. Please, if you have not subscribed to our YouTube video, please do so that you can have instant access to our educational resources each time we release them. My name still remains Sunshine, and I hope to see you in the next tutorials. Thank you very much.